Hi there, welcome back. We will now move ahead with the next session where we are going to be looking at, in the next two sessions, we are going to be looking at what we will typically call as an async sync bridge or a sync async bridge, right? And we will be looking at what are the options PI provides to build such bridges. So let's start first with what we call as an async sync bridge, right? Async sync bridge stands for nothing but asynchronous and synchronous bridges. How do you map or how do you build interfaces where one end system is asynchronous whereas another end system is synchronous, right? Let's explain the concept of an async sync bridge with an example. Let's take a case of a file RFC file scenario. We had built this scenario with a CCB PM with making an RFC lookup call in a message mapping in previous sessions, and now we will look at a different way of doing this. But before that, what is a file RFC file scenario? There's a sending file system that sends a file to PI. PI makes an RFC call to an ECC system. The sending system is asynchronous, the receiving system is synchronous, and the response that comes back needs to be put back into another file using a receiver file adapter. So one end of this flow is asynchronous wherever we are dealing with files. Remember, files are always asynchronous, whereas the other end of the system is synchronous because you're dealing with ECC where you're making a request and you're getting a response back. And that is why these kind of bridges are called async sync bridge, where the trigger of the interface is asynchronous. The interface gets triggered with an asynchronous file adapter. You then make a synchronous call, that's where the sync comes in, and then you again send a message back to a file system. So we will be building an async sync bridge in this session, and in the next session we will be looking at various variants of the async sync bridge and the sync async bridge, right? But in this case we will be looking at the async sync bridge, and we will be looking at this example, a file RFC file scenario that we are now going to build without a CCB PM. So very important to note, we are not going to do any CCB PM development, but how do I build this interface without a CCB PM? That's exactly what we are going to be looking. Right. So let's look at the various sections where you're going to be doing the development, and the async sync bridge that we will be looking at. We will be looking at the development that needs to be done using classical configuration and integrated configuration. So first we will look at classical configuration, and just as a recap, what is a classical configuration? A classic configuration is a configuration in PI where you have a sender agreement, a receiver determination, an interface determination, and a receiver agreement, and all of these four objects combine to form an end-to-end message. A classical configuration is only possible on a dual stack installation of PI. On a single stack installation of PI, you can only use a integrated configuration. All right. With that, what we are going to be building is our async sync bridge using a classical configuration, and the scenario that we are going to be looking at is a file RFC file scenario. So in the case of a classical configuration, let's look at the enterprise service repository for a file RFC scenario. The integration repository will be similar to any synchronous scenario, say an HTTP to RFC scenario. So what does that mean? In the enterprise service repository, your async sync scenario or the file RFC file scenario will have to be built the same way that we would build our HTTP to RFC scenario. So you will have one outbound synchronous message interface and one inbound synchronous message interface. So even though the file is asynchronous, we are now going to build it in such a way that the file's outbound service interface will be a synchronous service interface, and the inbound service interface where we are making a RFC call will be a synchronous service interface. Okay. Next, the receiver determination, interface determination will continue to be the same as our HTTP to RFC synchronous scenario. So nothing changes there. You will create a sender file adapter, you will create a receiver file RFC adapter, and you will create a receiver file adapter. The receiver determination and the interface determination will be the same. In the sender agreement, you will use the synchronous outbound service interface. In the receiver agreement, we will use the receiver RFC adapter. And that will be only one minor change that we will be doing is using in the file adapters, we will be used what we will call as a certain adapter module. So we will look at it when we are starting to build our configuration. So let's go ahead and start our development. All right. So as always, I'm going to my enterprise service repository. Oops, I don't I don't seem to have launched my enterprise service repository. So let me just go ahead and launch my enterprise service repository. I'll close my Eclipse. I don't want this for now. It's okay, this is nothing relevant, it was just some cleanup I was doing. The enterprise service repository might take some time, so we'll be back in a minute. Alright, so our enterprise service repository has now been launched. So I'm now going to go ahead, and as always the first step that I will be creating is defining a namespace. So I right click on my software component and I'm going to define a namespace. I'm going to call it training.com and let's call it it's async sync bridge / file rfc file _00. all right, so it's training.com. it's an async sync bridge which is file rfc file. all right, and I say create. Okay, I'll then call it name space for file rfc file for async sync bridge. all right, so my namespace is done. Where is my namespace? Here we go. Now let's go ahead and create our data type. So the RFC that we're going to be calling in our SAP backend is going to be the same BAPI user get details BAPI RFC. So now I'm just going to go here and define a data type, and the data type is going to be dt underscore file underscore request. Let's call it async sync underscore file request underscore 00. I'll just copy this. I'll say create. So my input structure is going to have just one name. It's going to be user ID. all right, XSD, and the user ID is going to be string. all right, next let's create a data type for the response. So I'm going to call it dt underscore async sync, and I'll call it file response. Create, and let's just add 4 fields. So insert element, sub element. Let's say first name. This will be of type XSD string. Then last name, insert element, last name. Again make it XSD string. Make sure that the occurrence is 0 to 11 because it's not mandatory. There in our SAP backend system we've already seen that it's not necessary that the first name is a mandatory field. So let's make everything as optional. dt first name, last name, and then let's just call one more field that says middle name. Right, let's just map that as well. dt XSD string, and I would say user 1. Perfect. all right, so this is my request data type and my response data type. Let's go ahead and create the corresponding message type. So I right click, I say new, I make sure I'm in the interface object, select message type, empty async sync underscore, let's just file request underscore 00. all right, now I'm going to drag my data type here. Make sure you're in the hand symbol. So my message type is created. Let's save our message type. Now let's create the new message type, empty async sync. I'm going to call it as file response and say create. And now I'm going to drag my response data type to my message type and save my message type. all right, next step is to create a service interface. So let's go ahead, close everything, say create new service interface, SIOS. it's going to be outbound synchronous. Remember, the enterprise service repository development will be like how we do a synchronous scenario. So you will need one synchronous service interface. It's outbound synchronous. So SIOS, let's call it as async sync underscore 00. all right, and let's make sure it's outbound. The mode is synchronous. Select the file request here. Oops, sorry, I did the mistake. Okay, let's fix that later. We'll fix it. File request here. Now the file response in the response. So the file request is the request message and the file response is the response message. Alright. I'm not going to create an inbound service interface because I'm making an RFC call to my backend. I don't need to create an inbound service interface. My RFC will act as my service interface. Now let's go ahead and create a mapping. So I'm going to go into mapping objects, say message mapping. Go to mapping objects, select message mappings, call it async sync file RFC file underscore 00. Alright. So this is my message mapping. Alright, there's a naming convention issue, so do not save. I'm just going to recreate my mapping. I'm going to call it, go into mapping objects. Alright, call it async sync file RFC file underscore request mapping, right? This is a request mapping. So my request source message is going to be empty async sync file request. Alright. My target message is going to be go into my imported objects, say BAPI user, get detail, and drag the BAPI. Alright. Perfect. So now my user ID is going to get mapped to the username here. Drag the user ID to the username, and my request message mapping is done. Let's go ahead, test this mapping. Go into the test tab and let's put a username. Let's call it admin user. Alright, and execute. Okay, perfect. This is done. So let's capture the source because this is going to be our request message. I'm going to just go into Notepad, save this message, go to my desktop, and then with my desktop, training, I'm going to have call this as async sync bridge underscore async sync bridge underscore file RFC file underscore .xml. Let's just call it that. Okay, and save this. So my request message is saved. Next, I'm going to create my response mapping. I'm going to call them underscore async sync bridge, and I'm going to call it as request, and here I'm going to say call this as a response mapping and create it. Now the response structure, it's going to be BAPI user get detail. So its request message is going to be the response. Because you're going to get the response from SAP, and now you're going to map it to the file response. So I'm going to drag the target message type as empty async sync file response. Okay. Now that I've done that, I just need to map the fields. So first name goes to first name, last name goes to last name, middle name goes to middle name. Alright. With that, my response mapping is also done. Let's go ahead and now create our next step is going to be an operation mapping. So right click on your mapping objects, make sure you're within operation mapping, say the name of the mapping, call it async sync bridge, async sync underscore file RFC file underscore 00. Alright. So my source operation is going to be, my source interface is going to be this outbound synchronous. My target interface is going to be my BAPI user get detail. So drag the BAPI user get detail and put it out here. Perfect. Say read operations. Now you see that because it's a synchronous, you have a request and a response tag. Now go here, select, you have your request, select that. Now go to the response. The response has the BAPI as the response, and select the message mapping, and the message mapping is now going to get displayed here. Alright. Now with that, the mapping is done. Okay. So our mappings are done. Now let's go ahead. Before we do anything else, let's go ahead and activate our changes. Alright. I'm activating my change. And perfect, my changes are activated. Alright. So now we are done with our enterprise service repository. From an enterprise service repository perspective, all the configuration that we did was like any other synchronous scenario. We didn't have to complicate anything out here. The changes or the little bit of the complications will come in the integration directory. And so let's go ahead and look at our integration directory configuration. Alright. So I'm in my integration directory. As always, I'm going to create a folder. I'm going to go into folder, say create. I'm going to call this folder async sync bridge underscore file RFC file underscore 00. All right. So let's look at my presentation here. What will we need to do? We need to create a sender file adapter, a receiver RFC adapter, and a receiver file adapter, right? So let's go ahead and create a sender file adapter, right? So right click, new communication channel. So let's go ahead, select DC file system 00, and our communication channel is going to be called CC Async sync bridge underscore file underscore sender underscore 00. All right, and say create. Okay, now this is my file, so I'm going to go here and select my file adapter. Okay, now for the folders, let's go into my training folder and get the directory structures. Yeah, here we go. So this is my input directory. I'm going to say please copy it from this directory, and I'm going to call the input file. We've already saved the input file, so I'm just going to copy the name from here and put the name here. It's called async sync bridge file RFC file.xml, right? Perfect. Then in the processing mode, I'm going to go in and make sure the file is set to delete. All right, with that my sender file adapter has been created. Okay, now we go ahead and create our next adapter, which is going to be our receiver file adapter again. So it's going to be BC file system 00 async sync bridge, and I'm going to call it receiver 00. I'll create the file. Okay, the adapter type is file, the direction is receiver, in this case it's receiver. The target directory will remain same. I'll just create a new directory here saying file RFC file. Okay, let's call it async sync bridge. Okay, and say classical configuration, because we need one for classical and I integrate it. All right, I'm saying create directory, and then we'll say file RFC file underscore resp underscore dot xml, because it's going to be a response file that gets created. All right, next go here, add timestamp, and my receiver file adapter is also created. Now we need to create a receiver RFC adapter. Now we're just going to recreate a receiver RFC adapter just so that we do it one more time. So my receiver RFC adapter is going to be created under EH5 client 800. So EH5 client 800, that's my SAP system. So I'm going to call it CC sync async bit, and I'm going to call it RFC receiver 00. All right, it's sync async bridge RFC receiver 00. Adapter type is going to be RFC because it's a RFC adapter. So select the adapter type as RFC, make it as receiver. All right, and let's go ahead and key in our details, right? So this is my SAP system. This is the application server. This is the instance number 28, and then I'm going to give my username. All right, so let's go ahead and make sure my user ID is working fine first in my ECC environment. Okay. Okay, so that's my username. I'm just going to go and get the username. Sorry, I don't remember it. Okay, so this is my username. I'll put my password here. English, and the client to which we have logged in is client 800. So I'm going to put the client as 800. All right. So with this, my receiver RFC adapter is also created. Let's leave what my notes say next. All right. Then the configuration, the sender agreement will be for the sender file adapter. Sender agreement will use the synchronous outbound message interface. Receiver agreement will use the inbound interface. So again, the configuration continues to be the same. So let's go ahead and create our sender agreement. So BC file system 00 is my sending system. Okay, you see why I've used a business component, right? So I need to add. So go into your business component, BC file system 00. You can double click here. You should see a BC file system 00. Remember, business components are not created in the SLD. They are created directly in the integration directory, and so you need to add your interfaces to it. So I need to go in and add my sender service interface. What is my sender service interface called? It's called SIOS async sync underscore 00. So I'm going to go here and I'm going to say please find the service interface for me. Yeah, this is my service interface. I'll say select this, perfect, and save it. Alright, perfect. So now let's go ahead and say new, create a sender agreement, BC file system 00. Now my service interface is displayed. For business components, you need to always manually add the service interfaces, whereas for business system, because they are created in the SLD, you do not need to add them. So in this case, for business component, we went in and added the service interface to it. Alright, so I've created this BC file system 00 and I'm going to say create. Alright, now once I say create, I select the sender communication channel, and my sender communication channel is going to be sync async bridge file sender 00. Perfect. Alright, now my sender agreement is done. So the sender agreement uses the file sender channel. Now let's go ahead and create the receiver determination. So it's asking me, I'll select the object, I say receiver determination, perfect. Now my receiver determination, who's the receiver of my interface? It's EH5 client 800, right? EH5 client 800, say save, go to configuration overview. It's going to ask for an interface determination and a receiver agreement. So let's say right click on the interface determination, say new specific, and select your operation mapping, and this is your operation mapping. Alright, so my interface determination has been created. I go back, I refresh, I go back to my receiver determination, I refresh, and when I refresh, now my interface determination is shown. Now right click and create a new receiver agreement. Say new specific for a receiver agreement, and here select your receiver communication channel. So the receiver communication channel is going to be CC async sync bridge RFC receiver. Alright, this is just receiver file RFC adapter that we just created, and with this our configuration is done. Right, so again the integration directory configuration so far is similar to any synchronous scenario that we built, except that in this case we now have a file receiver adapter as an additional. But what's now going to happen? This is not going to work. There are some other additional settings that we need to do, and that is where we go into this concept called adapter modules, right? So open up your file sender channel. Okay, let's close all. Let's first close all objects. Right click, say close all. Alright, open up your file sender channel, and so far we've never gone into this module tab, right? This is the first time we're going to go into the module. So before we just go into this module, and what you will see is every adapter of SAP has something called as a module. A module is nothing but something that denotes what the main functionality is, and you can always extend the functionality of an adapter by adding custom modules or SAP standard modules. So if there are certain features where you would need to extend the functionality of an adapter, SAP provides built-in modules which are called as standard modules, and you can also write custom modules that are called custom modules. So in this case we are going to use certain standard SAP modules that are available in every PI system. So we are going to go ahead and add those modules to the file sender adapter. So let me explain this one more time. Open your file sender adapter, and once you go into edit mode of your file sender adapter, make sure you're in the sender adapter, file adapter, and go into the module tab. Right now in the module tab you will need to copy this AF module / response bean. Alright, go here, click on the plus sign, alright, and add this. Alright, it is AF underscore module / request response bean. Select the type as local enterprise service bean and make this and call it as request REQ. Okay, it is going to deal with the request message. Then you need to, if you look at this, the order of the modules matter. So here you see the order. First module is a request response bean, the second module is a call SAP adapter, and the third module is a response one-way bean. So we need to move this up. So select the second line and move it up. So now perfectly, this module is the first request response bean, call SAP adapter is the standard SAP adapter. Now introduce one more module and move it down. Okay, so this is the third module, and you're going to call that as response one-way bean. Alright, let's make it as local enterprise bean and call it response RESP. Alright, and save. Now you need to add the configuration for these modules. So you've just introduced these modules. What does request response bean does? It changes the quality of service from exactly once to best effort. It changes the quality of service from asynchronous to synchronous, right? And then the standard SAP module will get called, and the AF response one way bean is to deal with the response structure. So let's go ahead and select add certain parameters. So for the first module, you need to add a parameter called pass through. So request, say pass through. Okay, make sure there's no space. When you're doing a copy paste, always make sure that there's no space. Typically you will end up with spaces, so make sure there's no space anywhere. There's no space here, there's no space here. All right, so you are saying request pass through, and then you're going to add 4 modules here. So let's add them 1 2 3 4 and call them response. All 4 are going to be response parameters. So what you're basically telling PI is, when the message is picked by the file adapter, the request response bean is going to convert the request structure into a synchronous message. Then the standard functionality gets executed, the response comes, and now the response is going to go get delivered to this particular receiver channel, and you need to give the receiver channel name. Alright, so I'm going to give the name receiver channel, I'm going to give receiver service. Adapter type, what is the adapter type to which I'm sending the response, and what is the adapter namespace. Alright, make sure there's no space. There's a space here because I did a copy paste, no space. Then let's give the name of our receiver channel. The name of our receiver channel is cc underscore async sync bridge underscore file. Sorry, here it is. I've done a typing mistake for file, so I'm just going to copy it. Okay, close. So this is the name of my receiver file adapter. The receiver service is bc underscore file system underscore 00. The adapter type is going to be file, file file, and the namespace, let's just copy it from here. It's going to be sap.com/xi/xi/system. All right, no spaces again. It should not have any space at the beginning and at the end. So with this, our configuration is done, and this is all that you need to do for a async sync bridge when you're dealing with a file adapter. All right, async sync bridge when you're dealing with a classical configuration. So in the sender adapter module, we introduced 2 modules, a request response bean and a response one-way bean. What is an adapter module? An adapter module is an ability to extend the functionality of an adapter. There are standard adapter modules and there are custom adapter modules. The role of a standard adapter module is something that is provided by SAP, and in this case the role of the request response bean is to convert the request message into a synchronous message, because when the file adapter picks up the file, it treats it as an asynchronous file, and you're telling PI, hey, please convert this into a synchronous message, right? Then the standard SAP module gets triggered, call SAP adapter. Now the standard functionality of PI will happen, your sender agreement, your receiver determination, your interface determination, and your receiver agreement, all the objects get executed, your pipeline gets executed, and now when the response comes back to the sender adapter, you need to tell PI what to do with the response, right? Your file sender adapter cannot obviously create a file, you need a receiver for an adapter. So you use a response one-way bean, and then you tell through the parameters of the response one-way bean, what is the receiver channel, what is the receiver service, what is the adapter type, and the adapter namespace. Alright, so let's go ahead, save our channel. I'm saving my channel, and now let's go ahead and activate. Before I activate, let's go ahead and upload our file into CG3Z, right? So I'm going to CG3Z. Alright, source on the file on the front end. Let's just copy this. So it's on the front end. Okay, my path is a little different. Alright, so this is my path. Source file on the front end, and my name of my file is this guy, and then the source file on the and the backend is also going to be the same. So then I just copy this here, sorry. So I'm just loading the file from my OS front end, from my Windows machine to my SAP system. Okay, I'm uploading. and my file has been uploaded. So now when I activate the change, we should see an immediate message get processed. So let's go ahead, activate and activate. My change list has been activated. Perfect. Now let's go cache status overview. Let's make sure that the cache is in green. All right, it's okay. The cache is just getting instantiated. Perfect. Now everything is in green. Now I go into my PI server. Let's log into SXMB AL11 and see if the file got picked up. All right. Sorry. Okay. Let's see first in SXMB Moni. Do we see something? Yes. You see BC file system. The request went in, came in. This was my request message, and this is my response message, and my first name, last name, and middle name is done. And now let's go to AL11 and see if the file got created. Okay. So /o AL11. I go into transport, training, async sync bridge, classical configuration, and this is my response. Perfect. So let's do this one more time. Let's see what happened in the communication channel monitor as well, right? So how do I go to my communication channel monitor? I go to my configuration and monitoring home. I go into adapter engine. I go into communication channel monitor, right? Now in my communication channel monitor, I'm going to give my sender file adapter's name, right? So my sender file adapter is, this is my sender file adapter. I say go. Perfect. I should have the message log here. So let's just click on this message log and see what happened in the audit, right? So message log, let's go to the message log. So the sender channel picked up this file RFC file. So it entered the so now if you see the log, it is saying request, entering request response bean, leaving request response bean, right? Perfect. This is what we wanted. Then it is trying to message, the message is getting processed. It's making a call to the RFC. You see the RFC was called, and now once the RFC was called, this is the RFC adapter. The RFC call was done, and now it's coming back into the response one-way bean. And once it sees that the response, it has to go to the response one-way bean. It is now transmitting the message to the response one-way bean using the file, and it is now delivered to the file adapter, right? And then it writes the file and it deletes the file to the file adapter. Okay, perfect. So with this, now let's look at the receiver file adapters log, right? So where is my receiver file adapter? Let's just quickly look at what happened in the receiver file adapter. I go to my communication channel monitor. I go here, I select my receiver file adapter and I say go. You see there's a message. Let's select this message. See if we can see something here. Perfect. Now if you go to the message log, it says, hey, I got this message, and you can see the same log, right? So with this, we come to an end of this topic. Before we just wrap this topic, let's just summarize what we just did here. We built an async sync bridge. An async sync bridge is where the sending system is asynchronous and the receiving system is synchronous. So we built an async sync bridge, and now that the async sync bridge was built, so far, and an example of an async sync bridge is a file RFC file, where a sending system is a file system. You make an RFC call and the response is pushed back into another file system. And to build this async sync bridge, what did we do? We first built a sender file adapter, which is now deleting the files. So the enterprise service repository configuration was the same as you would build for an end-to-end synchronous scenario, like an HTTP to RFC scenario or a SOAP to RFC scenario. So you build the enterprise service repository content the same way that you would build there. You define a request structure, you define a response structure, you define a one service interface, outbound synchronous. The reason we did not define an inbound synchronous service interface is because we are making a BAPI call. So we use the same BAPI. You define a request mapping and a response mapping, and you define one operation mapping because it's a synchronous mapping. Then in the integration directory, you created a sender file adapter, you created a receiver RFC adapter, and we created a receiver file adapter. Then the configuration is like any other configuration. You did a sender agreement, a receiver determination, an interface determination, and a receiver agreement. The only change was that in our sender file adapter, we went into the module tab. Sorry, this is the receiver file adapter. Yeah, we went into the module tab, and now within the module tab, you added these particular module chains. And once you added the module chains, the request response bean is used to convert the request into a synchronous call. The response one-way bean will then forward it to a receiver adapter. And you provide the parameters. If you call the request as REQ, you give the name REQ, module key for response, what is the namespace, what is the adapter type, what is the receiver channel, and what is the receiver service. And you save activated your change, and with that your async sync bridge was delivered. So the underlying fact is it is not always required to use a CCBPM. There are multiple ways in PI to be able to do the same kind of development, and one of the ways to build an async sync bridge is either to use a CCBPM or to build it without the CCBPM, as we saw here. With this, we come to the end of this session. We will now meet again ahead in the next session, where we will be building an async sync bridge, but instead of using a classical configuration, we will be using an integrated configuration, and we will be seeing how in the world of an integrated configuration the config changes a little. I shall see you soon again in the next session. Till then,